Welcome back to our series of fundamental programming. That's for beginners, complete beginners. In the previous lesson, that's lesson 4, we looked at interacting with the user. So in today's lesson, this is lesson 5, we'll look at expressions. So let me just bring up Notepad to write that so you see the spelling expressions like this. So what are expressions? Expressions in programming, they are actually they're like mathematical deductions, or should I say um, they are anything that provide that return a value. So the value doesn't have to be numeric, of course. If you remember, we looked at variables, and there are integers. That's the data types. In the different data types we looked at integers. That's int. We saw float. We saw bool. We saw string. What else did we? I think these were the 4 main data types that we saw. So basically, remember what a data type is just something that that defines the type of data. Okay, it kind of defines the type of data. The reason is because in programming, or a computer treat different types of data differently. So for example, what I mean by that is a computer, the way a computer stores an integer, so that an integer is just whole numbers 0, 1, 2, 3. The way it stores an integer is different from the way it stores a floating point number. That's decimal numbers 2.3, 2.4, 4.5, minus 2.3, those type of numbers. The reason is because for a floating point number, the computer needs much more memory to store. Okay, for example, between 0 and 10, for example, the number of floating point numbers between 0 and 10, obviously it's way greater than the number of integers between 0 and 10. Actually, the number of floating point numbers between 0 and 10, ideally it's infinite. But of course, there are methods, or there are strategic methods in which the computer uses. By approximations, it's possible for it to store floating point numbers between 0 and 10. Anyway, the main takeaway is that the way it stores a floating point number is different from the way it stores an integer, whole numbers, in the sense that it needs more memory to store floating point numbers than it needs to store integers. Comparing it to a bool, if you remember what a boolean is just a data that is either true or false. So in that case, it's just two different numbers. So actually, ideally, all a computer needs to store a boolean is just one bit. That's not even a byte. It's just one bit, not even up to a byte. Because using one bit, you can either store 0 or 1. So if it is false, it stores 0. If it is true, it stores 1. Something like that. So of course, this is probably a bool is probably the smallest data type. That's when looking at the way a computer stores it. Okay, I didn't mean to go through almost 5 minutes or 10 minutes explaining the different data types, but you get I just want you to get an idea of why you have to declare, or why you have to always tell the computer the type of variable you want to create. Good. Now that about data types aside, we're talking about expressions. Let me just type it. Expressions. Expressions in programming is just like I said, anything that returns or any mathematical no, not equation, any mathematical expression. I'm still repeating the word expression, but maybe you get what I mean. Any mathematical expression that returns or deduce a, a data that falls within the different data types that a computer can store. I hope that makes sense. Let me just give you examples. So, for example, 3 plus 4. The 3 is an integer, 4 is an integer. That is not it doesn't really matter what data type 3 and 4 is, but what matters is the result, the data type of the result. If you do 3 plus 4, what you get is 7, right? Now 7 is an integer, right? So in that case, 3 plus 4 is an expression, because it returns this expression returns, or it deduces into a data that is an int, right? Because it deduces into 7, which 7 is an int, or is a data type of int. So in that case, 3 plus 4 is an expression, right? I just hope this makes sense. Another example, of course, is 3.7 minus 1.0, for example. Okay, 3.7 is okay. Let's not forget our f. Remember, in program or in C#, you always have to add an f after a floating point number to show that it's a floating point number. So 3.7f minus 1.0f, and the result you get is 2.7f, which is a floating point number, which is a float. In that case, this is an expression. Okay, now expressions don't have to be this simple, right? Expressions can actually be, in fact, I think we should go ahead and just open Visual Studio and start seeing how we can use these expressions. Okay, I just wanted to give a brief overview of what expressions are, so you understand. Let's launch Visual Studio, or let's open our application. Okay, so on my desktop, I opened in my apps folder, my first app, and this is the solution. I double click on it and Visual Studio runs. Let me minimize that, and it loads our program. Okay, this is the program we did in lesson 4. We'll just, should we erase that? Maybe not. Okay, here's what we'll do. Let me introduce you to this this double slash. That's a backward slash double. Notice what happens immediately I put a double backward slash before this console.write, like before this statement. Okay, just here I'll put a double backward slash, and notice what happens. Everything here has now turned to green. Look at it, it's now color green. That is telling you that this is a statement. Okay, it means that when the computer when the computer wants to run this program, it should completely disregard this line, this particular line. It should disregard it. It's telling this double slash at the beginning, saying please disregard this line. This is just a comment. This is a comment I'm writing to myself. So for example, the use of this double slash, ideally they are actually meant for writing comments for yourself, the programmer. Okay, so sometimes, you know, your program can be as long as say 1,000 lines of code. So sometimes in your program you might want to write or keep short notes on what you're writing. So for example, I'll just say below is the code we wrote for lesson 4. Okay, so you can see nothing is underlined in red. Also, everything there on that line is highlighted in green, or is converted to color green, because when we try to run this application, this line is completely disregarded. The computer just says, okay, that is not my problem, it's not my cup of tea, you wrote that, it's meant for you, it's not meant for me. Okay, so you usually use this double slash for commenting your code. So you can write whatever you want to write here after the after the double slash, double backward slash. Another method you can use is the a backward slash followed by an asterisk. All right, now see what happens if you put a backward slash followed by an asterisk. Anything after that is going to be commented out. Notice that everything here is commented out, and then Visual Studio is telling us, oh hey, there's an error because you opened this curly bracket, you didn't close it, you opened another curly bracket, you didn't close it, you opened another curly bracket here, you didn't close it. That's because all these curly brackets that are supposed to close these 1, 2, 3, they are all commented out. The computer is disregarding them. So what you do after you put a backward slash and an asterisk is you can put anywhere within your code that's after this backward slash and an asterisk. You can put, oh sorry, I've been calling this a backward slash. This is actually a forward slash, pardon me. This is a forward slash, so this is a double forward slash. This is a forward slash asterisk. So I'll come down here after the last line of code and I'll add an asterisk. Notice the difference. Here you put a forward slash first, then the asterisk. However, when you're closing it, you put the asterisk first, then followed by the forward slash. And notice what happens. It's telling the computer that this is where my comment ends. Okay, you're saying this is where the comment starts, so disregard whatever comes after this until you meet another asterisk and forward slash, then you can terminate it. You're saying this is where my comment ends, so you can now continue regarding whatever I write as code. Okay, the reason I introduced you to this commenting method is because I always use this. I'm sure not myself. Sometimes you'll find out that you wrote some piece of code in your program and then you realize, hey, maybe you don't want that code, but you're not sure. Maybe in the future you might need it. So instead of deleting the code entirely, it's better you just comment it out. Okay, you can just comment it out, leave it there, continue writing. The program, whenever you run the code, the program is not going to execute those lines of code because they are comments. They are now comments. You've converted them to comments. And then whenever you realize later in your code, hey, I really need those lines of code, you can just come back, uncomment this, and voila, you are back in business. The code is released, and then the computer can now reconsider the code. Whenever you run it, it's going to consider these lines of code. Okay, all this explanation is just so you don't get confused when I do this. So I just want to comment this out because we don't want this part of the code for lesson 4 for now, but we don't want to delete it. We want to keep it in our program as a comment so that later we can uncomment it if we want to use it. Okay, all right, now back to expressions. Okay, we are talking about, yes, expressions. We're talking about how we create expressions. I was telling you that 2 plus 3 or 2 plus 4, for example, this is an expression. But notice something about expressions. Expressions are not themselves statements. Okay, so if you write something like this, 2 plus 4, and then terminate it with a semicolon, this might actually run if you're using Python, for programming, but we're using C sharp, and in C sharp, expressions alone or expressions themselves do not make a valid statement. Please take that, keep note of that. This is a valid expression, however, it does not make a valid statement. So you can't just write, because this returns 6, you can't just write 2 plus 4 and say that's a statement. You're not telling the computer anything. Yes, this returns 6, but 6 what, right? The computer is thinking, okay, you just said 6. What am I going to do with 6? Okay, in Python, the reason why that will run is because probably in Python, when you want to use your console.writeLine, right, you don't need to write it out, console.writeLine. You just write whatever whatever you want to write out, right? Like you want to write out 6, you just write 6, and it just uses it internally. Python will do the console.writeLine 6 for you. But in C sharp, if you want to display 6, you have to do something like console.writeLine, right? You remember we looked at this in the previous in lesson 4. We saw the console, yeah, that's here, console.writeLine method. Okay, console.writeLine, and notice we're writing 2 plus 4 inside these brackets. The reason is because the writeLine method allows you to enter an expression in between the brackets. So all we have been doing all this while, all this hello everyone, we're writing what is your name inside these brackets, inside these normal brackets of console.writeLine. These are actually expressions, okay? They are expressions. For example, this expression, this hello everyone expression, well, not now because now we've commented out the code, but assuming we didn't include those comments, this is a string expression. This is another string expression here. What is your name is a string expression. Hello plus user, remember this, we use a hello and then we concatenate it with username. This is a valid expression. It's actually, it returns a string. Here in this expression, we're returning an int. The reason is because we're putting in an int plus another int, okay? Usually when you do an integer data type plus or whatever operation with another integer data type, what you're going to get returned is another integer data type, okay? So 2 plus 4 here is going to return 6. So let's just run that to make sure that that works fine. Okay, so we've run our code. You can see at the top there, this is our 6, right? That's what just got displayed. So that is a valid expression, okay? Now, like I was trying to explain, expressions don't have to be this simple, okay? You can actually have things like 2 plus 4 times 5 divided by 3 minus 2. Okay, this is another valid expression. However, I'm pretty sure this expression is not going to run the way you expect it to run, and there's a reason for that. I remember in mathematics, in early elementary mathematics, when we were taught mathematics, when we have complex combination of operations and operands like this, they always told us to use board mass, something like this. Some people call it bed mass, with E as exponent or O as order. Ours was board mass anyway. B was brackets first, so you actually execute, you try to compute whatever is in brackets first, then you compute what is in order, right? That's the exponentials. Then you compute what is in division, then you compute multiplication, then you do the addition, then you do the subtraction. However, I want to warn you that will not work for C#. Okay. My advice, my biggest advice I'll give you to avoid any confusion about what is going to get executed first, you should always, whenever you have a lot of operands and operations like this, and you know, of course, beforehand, you know the order you want to run it into, right? You should just use brackets. Use as many brackets as you can. Okay, so for example, what we want to do is we want to add 2 and 4 first, and then after adding 2 and 4, we want to subtract 2 from 3, and then when we do that, we want to divide 5 by the result here. So we want to do this first, and then at the end of it all, we want to multiply by the result here. So what we do is, remember I said we'll execute this first, the result, we do 5 divided by the result, then the result of that we do multiplication of 4 plus 2, a multiplication of the result of 4 plus 2 and the result here. So since you know that's the order you want to do, what you do is put this in bracket. Okay, the 3 and 2, you put them in brackets, right? Then you put the 5 and, okay, I know we're going crazy with the brackets now, but don't worry too much about, I'll explain. I'll just finish and then I'll explain. Then put the 2 and 4 in brackets also. Now by doing this, what we've done is we've done something like this. We did when it comes, okay, console.writeLine, remember this first open bracket is for the console.writeLine, so we're going to disregard that. Let's go down to the next and break this. So this is for this, right? I'll just paste that out well so we see how everything is executed, right? And I'll shift this here. I just want you to have a visual view of what's going on. So when it comes to console.writeLine, right, it opens a bracket, and this is the pair of bracket that closes this. So we're now inside here to see what expression is going to get executed. The next thing it comes over is 2 plus 4 in brackets, right? So it opens that bracket, does the 2 plus 4, right? Closes that bracket, and then it does the multiplication with whatever is down here. Open another bracket, right? Okay, so let's tap that. Does the 5 okay, it won't do the 5 divided by yet. It opens another bracket. Let's tap that, and then this is the closing bracket of this, right? And then it does 3 minus. I'm just spacing this out. I want you to see exactly what's going on. So if it comes in, it does 2 plus 4. The result here is going to keep it here, and then do multiplied by, actually it's going to keep everything here one side, right? This is where execution actually starts, right? Because this is the root, or let's say this is the end, this is the ending node. It does 3 minus 2, right? That's 1. The result comes up out here, does 5 divided by 1, which is 5, and then it brings the result out, multiplied by the 6 here, right? That's 6 times 5, which is 30. So we expect to see 30, right? And abracadabra, what do we get there? 30. Okay, I know this is probably not the best way to explain this, but I'm just running out of ideas of how to explain this. But I think this should make some sense. Okay, let's close that. Let's see if there's a better way I can explain this. Now think about this. whenever you see brackets, right, just make sure you compute what is enclosed in brackets before you go to the outer brackets. Does that make any sense? Okay, so this is a bracket, this is a bracket. We must compute what is inside this before we go out, right? Good. There's another bracket open. This is the pair of bracket that closes this, right? So we must compute what is inside this before we go out, right? So this is the bracket that tells us we're going out of this open bracket. Okay, so we must compute this. So 4 plus 2 is 6, right? Now we are out of this bracket, and we're supposed to multiply with whatever we get inside this bracket. Okay, by doing it this way, I think you force calculations using brackets. Because when you use brackets, if you remember your board maths in mathematics, whenever you see brackets are always executed first. It's the same thing with the computer. Brackets are always executed first, right? So by forcing brackets in your expressions, you enforce that board mass principles that you already know. Okay, that's why I was suggesting you always use brackets when you have a very complicated expression like this. I know this is probably taking too much time in trying to explain this expression, and by the way, you don't have to space out expressions like this the way I just did. So that's why I'm putting them back the way they should. They shouldn't take too much space. Let's just take it back. Okay, and let's take this back. I want to make sure they're just on one line, right? Okay, so we're back to one line. I just hope that makes some sense. I'm not sure if it does, but I just hope it does. Okay, another way you can think about it is whenever you enforce brackets, whenever you have an operator, that's a plus, a multiplication, a division, a subtraction symbol, an exponent symbol, or whatever operation, always make sure you enclose the operands of that operation in an open and a closed bracket. Does that make sense? So for example, this multiplication symbol, this is the bracket that opens, which is the same bracket that starts the right line, and the same bracket that closes the right line. It is what encloses this operand, right, and this operand. And then for this division, right, this bracket is the open, and you can see this is the closing bracket, the one highlighted in blue, that encloses this operand and this operand. I hope that makes sense. Anyway, let's just leave out, because the thing with expressions is that this is just one type of expression we've looked at, right? There are several different types of expressions. This particular expression I've just shown you is the expression of int. Okay, the reason is int is because it returns an int. It returns a value of the int data type. Now, another type of expression is console.writeLine. Remember, the console.writeLine is not actually part of the expression. However, the console.writeLine allows us to display the expression to the viewer, right? That's the result of the expression. So, console.writeLine. Let's put, okay, before this, let's say, in fact, let's do this. I'm going to remove this console.writeLine. I'm going to remove this bracket, okay? Okay, now I'm going to say int some expression. Notice I'm writing some expression starting with small letters, and then my E is capital E, so don't forget that. Int some expression. I've declared, remember this is a variable now, I've declared it that it's going to hold an int data type, and then I'm going to say some expression is now, I should take, remember this is saying take whatever is on the right hand side, right? The right hand side is now an expression. Okay, take this expression on the right hand side, the result of the expression, and store it inside this variable, right? And then in console.writeLine, I'm going to say write some expression -5, right? And then close that semicolon. Oh, okay, let's make this, okay, let's just leave that -5. We're still using an int. This expression is still of type int. I'm just doing this so you see what you can do with expressions. The result of combining an expression and then using an operation on it with another operand of, remember this 5 here, even though it's a data, it's a data, or it's a like it's a unit of data, it's still it's still an expression on its own. So saying this variable, which is we took this expression, the result of the expression, stored it inside it, and then we're using it to calculate or to deduce or to create, we're creating another expression using this expression. Okay, does that make sense? We're using we're using an expression that we've already created plus or minus another expression, so that is allowed. I just wanted to show you that you can actually use some expression plus another expression, or some expression combined using an operand, using an operator and another expression. Okay, now this minus times divide, by the way, look at the way we do we use the times symbol in C#. It's a star. We use a star to denote times, not x. Okay, a plus, a times, a divide by, a subtraction symbol. All these operators are operators that can operate on int expressions. Okay, all expressions of that return integer data types, you can use these operators on them. Okay, the reason I'm saying that is that there are some data types, like the string, for example. The string, you cannot use a multiplication. It wouldn't even make any sense anyway. You cannot use a multiplication symbol in a string. So for example, what I mean is, you can't say string x, right, and then x is equal assign let's say, let's say Sunny asterisk say sorry about that, hy. Okay, so we have a string expression here, and then another string expression here, and we're using the multiplication symbol operator. This is the multiplication operator. Exactly, look at what the comment is saying. Read that comment while it's on the line in red. Operator star cannot be applied to operands of type string and string. That's a very good error message. Okay, it's telling you that this operator symbol cannot be used between, because X is a string, right? This Sani is a string, HY is a string, so you cannot use this operator to combine these types of data types. However, if you look at above, the way we used it here, we actually used it in int. Some expression is an int data type. Okay, we can actually use it in int. So by that, the thing we should do is, I think I should show you all the valid expression, all the valid operators, and where you can use them. That's what type of data types you can use for. Before we do that, let's just run this program and just make sure this makes sense. So remember, this operator, this expression returned 30, and we're saying some expression minus 5, so we expect to see 25, right? Let's just run that. Yeah, 25, so that makes sense. It runs. Okay, back to what I was trying to explain, right? I was trying to show you that I was trying to say we need to show all the different data types and all the operands you can use to create expressions. Okay, so the different data types, we have int. We've seen int. You can use plus, you can use minus, you can use multiplication symbol, you can use division, you can use even the power. This is the exponential symbol. Okay, so for example, you can say int x is equal to 2 to the power of 4, for example. Okay, so this is the exponential symbol. So these are all the those are all the operators you can use. I'll just use this as a comment. So for int, you can use plus, minus, divide by, multiplication, and the power or exponential. These are the different operators you can use to combine and create expressions of type int data type. The next we have is float. Remember our float, the floating point numbers, which use that's the decimal numbers. Okay, 2.3 minus 99.2, whatever. And they always take an F. Don't forget that. They behave like the ints, like the integers, in the sense that the same set of operators can be used. So you can use plus, minus, divide by, multiplication symbol, and the power symbol or the exponent symbol to create expressions of type float. Okay, the next is string. Yeah, the string, however, like we saw, I think there is only one operator that works on the string, which is the plus, and we used it here. If you remember, we used it here in console in the lesson 4. We used it in saying console.writeLine hello plus username. Remember, username was a variable, so it took whatever it was in the variable, concatenated it, that's joined it with this hello, and then displayed it. Okay, so this is the only valid operator you can use on string data types to create expressions. Okay, so like what that means is you can do something like this. Console, you can use do something like this: hello in quotes plus another string or another variable which is of string data type. Okay, by this time you should probably have realized that even a variable is considered as an expression. Okay, a variable like this username string, username is a variable here, and then we store something inside the username. Username equals console.readline. Remember the readline method, whatever the user types gets stored inside the username, inside this variable. Okay, Now look at how we used it here. Username, and then we use a plus in between username and another string, which is hello. Okay, that's just to show you that even variables are themselves expressions. Okay, hope that makes sense. Then the last one we haven't looked at is the bool. Now, the bool has a completely different set of operators, and these are the operators for bool. We have the OR operator, which looks like this. Sorry, not that. It doesn't look like that. It looks like, oh my word, how do I find it? Okay, let me just change my keyboard. Let's change it to this. Okay, I should be able to type that now. Yes, that's the OR symbol. It's two straight vertical lines. I don't know what you call that on the keyboard, but it's directly above the key that has the backward slash, this backslash. Okay, if you look at your keyboard where you have this backslash, not the forward slash, this is the forward slash, this is the backslash. Okay, where you have the backward slash, above it you have this symbol. Okay, so you'll have to use shift and then press on that key, and then you get that, and you have to put it twice. Okay, you can't just write it once. You can't just write it like this. This doesn't make sense. It has to be twice, and this is called the OR operator. Let me just open Notepad and write that. So that is it's called the OR operator, OR. Now, it's a logical operator. If you've done logic in mathematics, that's just what this operator does. It functions as an OR operator, just like the normal OR operator in logic. Okay, I'll try to explain that. Let's just look at all the different operators we have for Boolean. There's also the AND operator, which looks like this, double ampersand. Okay, and then there's the exclusive OR. I'm not sure there's an exclusive OR. You might have to create it yourself. Okay, I don't think there's an exclusive OR. There is a NOT, however. That's the NOT operator, and it's written like this, a NOT. And what else is there? I think these are all the Boolean operators. Yeah, I believe they should be all. So there's an OR operator, an AND operator, and NOT operator. Those of us that have done mathematics, I think there is something like the XOR operator, which is the exclusive OR, and there's probably a ZAND, which is an exclusive AND. I'm not sure how you would create this, but if you look at your logic in mathematics, there are ways you can use OR, AND, and NOT. These three, you can use these three to deduce these and this and this. So these two are not actually that important. Okay, you can always use, if you have a NOT, an AND, and an OR, you can always combine them to create a XOR and an AND and a ZAND. Okay, so let's just eliminate that. We don't really need that. So for Boolean, we said there is the OR operator, the AND operator, and the NOT operator. Okay, how do these operators, we've seen how these operators work. By default, we know from our knowledge of elementary mathematics, we know how ints work with these operators. Okay, that shouldn't be a problem. We know the same thing with floats. It's just that these are integers, these are floating point numbers. Don't really make any difference. We also know how these operators work. We have seen how the plus operator works on string, in the sense that it just joins two strings to form one giant string. Okay, For these operators, let's have a look at how these operators work. Now, remember a bool. Let's declare a Boolean variable. Call it my Boolean. Okay. So my Boolean is the name of the variable, and oh, sorry, it's supposed to be here. And after creating this variable, I'm going to store true inside. Okay, my Boolean, assign it true. Notice how I write the true. I just write true. Don't put it in quotes. Okay, unlike string, you just put it. Remember, a Boolean stores either true or false, nothing else. It can only be two different values, true or false. Okay, so we're going to store true inside there. Now notice what happens. Let's take the simplest operator, Boolean operator, this not. If you take a not, okay, what happens if you apply a not on, actually a not works on only a single operand, unlike the plus, the minus, the division, the multiplication, the power. You always use them in between two different expressions, right? Like here we used a concatenation between hello and username, and in where we wrote 2 plus 4, we used a plus symbol in between 2 and 4. 2 is an expression, 4 is an expression. For a Boolean, for these not operator, you only use it with one operand. Okay, for these two, the and operator and the or operator, you actually use them in between two expressions. But for this one, it's different. It's used only on one. So we'll see that we can actually do something like this. Console. Okay, no, not console.writeLine. How do we display this? Okay, I'm thinking of how we can actually display. That's going to be a big challenge. Okay, anyway, I'll just explain, because I don't want us to go into classes until later, because I don't want to bother you too much with classes. Okay, I'll just explain it, and hopefully we'll understand what I mean without actually running anything. Okay, what we'll do is we'll say we can do something like bool another Boolean. Okay, so what I'm doing is I have created, remember this is a variable, I just created a variable. I said it's going to store Boolean Boolean data types, and I called it my Boolean, and then immediately I store true inside it. Now I create another Boolean, I create another variable here, and I called it another Boolean, and I said it's going to store Boolean data types or bool data types. Then I'm going to say another Boolean, assign it not my Boolean. Okay, now notice what I've done here. Okay, don't forget the semicolon. Notice what I've done here. I added a not operator on only one expression. I didn't put a Boolean expression and then put a not and then another Boolean expression. No, that's not how you use it. You use the not operator just before the Boolean expression you want to use. Remember, I said a variable is also considered as an expression. Okay, so now what I'm saying is it should take whatever is on the right hand side and store it inside whatever is on the left hand side. Now who can guess what is going to be stored inside another Boolean? The value false is going to be stored inside this another Boolean variable. Okay, I hope that makes sense. The reason is because we said my Boolean, it should store true. Okay, This not, what this not does, this exclamation, the not operator is just an exclamation symbol. Okay, what it does is it just says, it just negates, it kind of says whatever is inside this boolean, I'm going to take the other data. Okay, remember, a boolean can only be true or false. Since true is stored inside this my boolean, this not is going to take the other data, which is not true. Okay, not true is false, right? I hope that makes sense. I don't know, I don't know any other way to explain it, but I'm just hoping you'll understand. So another boolean, what's going to be stored inside another boolean is false. Okay, so another thing is, let's change this to false. In this sense, oh sorry, false. In this case, what will happen is false is going to be stored inside my boolean, and then we say another boolean, store not my boolean. Since my boolean, when it picks inside this variable, what it's going to see is false, it will now negate that false because of this not operator. It will negate that false, and what that will what this expression will evaluate to is true. Okay, so it will store true inside another boolean. Hope that makes sense. I don't know if that makes sense, but that's going to be the explanation for the not operator. Maybe that's more difficult than the others. Anyway, let's look at the OR operator. The way the OR operator works is, suppose we have my boolean, we store false inside, and then we have another boolean, we store, let's say we store sorry, I don't want to do that. Let's do this here. Let's say we store false again. Okay, so we store false here, we store false here, so we have two boolean variables, right? And then we create another boolean again. Let's say a third boolean. That's what I'm going to call this. So this is a variable, and I called it a third boolean. And then I say a third boolean, assign it. Now I want to use this my boolean. Sorry if I can spell that. My boolean. Come on. My boolean, or where's the or symbol? Here it is. Or another boolean. Okay, I see. Maybe I'm making this as more complicated than it needs to be. So I'll just remove all that, and I'll just use true here. True or false. Okay, now what am I saying? I've just created a boolean here. I called it a third boolean, and then I say a third boolean, assign it the value of this expression. Okay, this is an expression. Notice how you use the or symbol. You use the or operator in between two expressions of bool. Okay, two boolean expression. So what's here? This is a valid boolean expression, this is another valid boolean expression, this is true, this is false. What it does, you know how the or operator works. When you take a true and you or it with a false, the result you're going to get is a true. Okay, when you take a false and you or it with a false, the result is going to be a false. Now I think the best thing you can do to know everything about logic, actually logic is such a very simple and straightforward topic in mathematics. For those of you that haven't done logic, I think it might make some sense to just look at the basics. Okay, you might have to go and look at the basics of logic in mathematics. It's believe me, it's very, very simple. It's just for you to know these operators: the or operator, the and operator, and the not operator. You've already seen how simple the not operator is. The not operator just negates. And remember, in logic, a unit data in logic is just a true or a false. It can't be any other thing. Okay, so I highly recommend you look up logic and see all the, we call them truth tables. Okay, look at all the truth tables for or, for and, so know what happens if you do false or false. Okay, know what happens if you do false and false. Know what happens if you do false or true, and know what happens if you do false and true. And then know what happens, like all the different combinations of true and false, true or false, false or false, false and false, all the different combinations. Know the results. It's actually very, very simple and straightforward, like I said before. Always think about it this way. Think about it as if they are statements. Suppose you have a true statement. Suppose you have a false statement here. Okay, and then you have another false statement. And then someone makes a statement and says either this statement, that's the two statements are either true or false. Now, what that means, oh God, I think this is going to be very difficult to explain. Okay. I think the best thing you can do is just to look up logic. Okay, look up logic. That's the best. It's going to be extremely difficult for me to sit down here and try to explain it, and try to explain how they deduced the values for when you do false or false. Okay, just look at truth tables. That's the best way you can easily understand Boolean. Okay, just know that if you do false, if you do a Boolean expression or another Boolean expression, what you're going to get is a Boolean expression. That's everything is going to deduce into a value that is a Boolean expression. Okay, now also I want you to keep in mind that you can actually do something like this: false or false, put them in brackets, and then and it with say true, and let's add another not that, and then at the end of it all, let's put everything in brackets and then use a not. So what we're saying is do false or false, whatever you get as the result, you AND it with true. Whatever you get as the whole result, you NOT it, that's you negate it. Okay, so this is another valid Boolean expression. And remember, using these brackets, you can create as complicated Boolean expression as you like. It can be as complex as you want. Okay, there's no limit to the to how complex a Boolean expression has to be, or not just a Boolean expression, any type of expression. You can always use brackets to formulate complicated expressions. I'm going to stop here in this lesson. This lesson has gone far too long, and it's by far the most difficult lesson I've done. I don't even know if people are going to grab and understand, but hopefully I'll keep my fingers crossed that at least you've picked one or two things in this lesson. The whole point of the lesson is expressions, to show you that you can actually have complicated expressions stored, that's the result of complicated expressions stored into a variable, and a variable itself, the data that you store into a variable, is by itself an expression. I'm going to stop here. Like I said, fingers crossed you've picked a thing or two, and don't forget to look up logic in mathematics if you haven't done in your elementary maths class.